Welcome to IIOCS.com Food Tech Club. Today's topic is spice processing. The history of herbs and spices is as long as the history of mankind. People have used these plants since earliest time. No other commodity has played a more vital role in the development of modern civilization as spices. The lives of people and plants are more entwined than is often realized. Some herbs have the power to change our physiological functioning. They have revolutionized medicine, created fortunes for those who grow, process, and treat them, and in many cases have assumed social and religious significance. Even today, we continue to depend on herbs and spices for many of our newest medicines, chemicals, and flavors, and they are used in culinary preparation, perfumery, and cosmetics. Herbs and spices have tremendous importance in the way we live and as ingredients in food, alcoholic beverages, medicine, perfumery, cosmetics, coloring, and also as garden plants. Spices and herbs are used in foods to impart flavor, pungency, and color. They also have antioxidant, antimicrobial, pharmaceutical, and nutritional property. In addition to the non-direct effect, the use of these plants can also lead to complex secondary effects such as salt and sugar reduction, improvement of texture, and prevention of food spoilage. The basic effects of spices when used in cooking and confectionery can be flavoring, deodorizing, masking, or pungency and coloring. They are also used to make food and confectionery more appetizing and palatable. Some spices such as turmeric and paprika are used more for imparting an attractive color than for enhancing taste. The major color components in spices like carotenoid from beta carotene, which is give reddish orange. The source is red pepper, mustard, paprika, saffron. Whereas lutein, which is a carotenoid, which gives dark red color, the source is paprika and parsley. And for curcumin, the coloring compound curcumin, which gives orange yellow, the source is turmeric. Chlorophylls, which gives green color, is from herbs. Because of their antioxidant and antimicrobial properties, spices have dual function. In addition to imparting flavor and taste, they play a major role in food preservation by delaying the spoilage of food. Many herbs and spices have been used in cosmetics, perfumery, and beauty and body care since ancient times. The toiletries and allied industries use spices and herbs and their fragrant oils for the manufacture of soaps, toothpaste, face packs, lotions, freshness sachets, toilet waters, and air oils. They are essential ingredients in the beauty care as cleansing agent, infusion, skin toners, moisturizer, eye lotions, bathing oil, shampoos and air conditioner, cosmetic creams, antiseptic and anti-tanning lotions and creams, improvement of complexion and purifying blood. Herbs and spices are rich in volatile oils which give pleasurable aromas. In addition, herbs may contain alkaloids and glycosides, which are of greater interest of pharmacologists. Some of the main constituents in the herbs are acids, alkaloids, acids which are sour, often antiseptic and cleansing, alkaloids which are bitter, often based on alkaline nitrogenous compounds. They affect the central nervous system and many are very toxic and addictive. Anthraquinones which are bitter, irritant and laxative, acting also as dyes. Bitters, various compounds mainly iridoids and sesquiterpenes with a bitter taste that increase and improves digestion. Next, coumarines are antibacterial anticoagulant with a smell of newly mown hay. Flavones, which are bitter or sweet, often diuretic, antiseptic, antispasmodic, and anti-inflammatory. Typically yellow and present in most plants. Glycosides, there are four main kind of glycosides: cardiac, cyanogenic, mustard oil, and sulfur. Gums and mucilages, these are bland, sticky and slimy, soothing and softening. Next we have resins, saponins, tannins and volatile oils which are aromatic, antiseptic, fungicidal, irritant and stimulant. Herbal spices or leafy spices are annual, biennial, perennial plants, the leaves of which, fresh or dry, are preliminarily used for flavoring foods and beverages. Apart from being used as flavoring agents, herbal spices are also known to possess nutritional, antioxidant, antimicrobial and medicinal properties. Because of the attractive foliage, a few herbs are also used as garnishing spices in many food preparations. The essential oil extracted from tender stems, leaves and flavoring tops are used in cosmetics, perfumeries and toiletries, and for flavoring liquors, soft drinks, beverages, and pharmaceutical preparations. ISO document 676 list ISO document 676 list 38 leafy spices. Allium tuberosum, with common name Indian leek, Chinese chive, stony leek, Japanese bunching onion. The plant part used as a spice of bulb and leaf. Allium porum, which is a common name winter leek. The part used as a spice is leaf and bulb. Anethum graviolanus, with a common name dill. The part used as a spice are fruit, leaf, and top. The functional properties. The nutritional property: most of the herbal spices are rich source of protein, vitamins, especially vitamins A, C, and B, and minerals such as calcium, phosphorus, sodium, potassium, and iron. Parsley is the richest source of vitamin A, while coriander is one of the richest source of vitamin C and A. Parsley and chervil are also rich source of vitamin K. Antioxidant properties. Antioxidants are added to foods to preserve the lipid components from quality deteriorations. Synthetic antioxidants such as butylated hydroxyanisole (BHA), butylated hydroxytoluene (BHT), propyl gallate (PG), and tetrabutyl hydroquinone (TBHQ are the commonly used synthetic antioxidant. Owing to their suspected actions as promoters of carcinogenesis, there is growing interest in natural antioxidants. Many herbal spices are known as excellent source of natural antioxidants, and consumption of free herbs in the diet may therefore contribute to the daily antioxidant intake. Phenolic compounds are the primary antioxidants present in the spices, and there is a linear relationship between the total phenolic content and antioxidant properties of spices. Essential oils, oleoresins, and even aqueous extracts of spices possess antioxidative properties. The plants of the Lamiaceae family are universally considered as an important source of natural antioxidants. Rosemary is widely used as an antioxidant in Europe and the USA. Oregano, thyme, marjoram, sage, basil, fenugreek, fennel, coriander, and pimento also possess antioxidant properties, better than that of synthetic antioxidant butylated hydroxytoluene. Phytoconstituents such as carvacrol, thymol, rosmarinic acid, and carnosic acid are responsible for the antioxidant property. Antimicrobial properties. Herb spices are an important source of antimicrobials, and the use of spices, their essential oils, or active ingredients for controlling microbial growth in food materials constituents an alternative approach to chemical additives. Some of the spice essential oils, individual or combinations, are highly inhibitory to selected pathogenic or spoilage microorganisms. The fractionation of essential oils and further applications helps to improve the level of activity in some cases. The optical isomers of Carboniferum, Mentha spicata, and Anathum sova, that is Indian Del, were more active against a wide spectrum of human pathogenic fungi and bacteria than the essential oils as such. Mixing compounds such as carvacrol and thymol at different proportions may exert total inhibition of Pseudomonas aeruginosa, and Staphylococcus aureus. The inhibition is due to the damage in membrane integrity, which is further affects pH homeostasis and equilibrium of inorganic ions. Such knowledge on the mode of action helps spice extracts ingredients to be applied successfully in food. Also, application of active ingredients instead of essential oil will not change the food's flavor very much. Plant extracts or seed diffusates could be used for the control of seed-borne pathogens and can be a substitute for costly chemicals for seed treatment. Plant extracts of pimento can be used for controlling fungal growth during storage of wheat grains. Likewise, the seed diffusates of Anthum graveolens and Coriandrum sativum give a high level of growth inhibition against seed-borne fungi such as Alternaria alternata and Fusarium solani. Of the various herbal spices, oregano and thyme show the highest antimicrobial activity. Carvacrol, present in the essential oils of oregano and thyme, has been proved to be the most important fungi-toxic compound. Insect repellent properties. The herbal spices have good insect repellent properties. Powdered plant extract or extracts of seeds or essential oils or active ingredients separated from essential oils and oleoresins of spices are used as insect repellents. The repellent action is noticed against many storage beds of grains and pulses. Herbal spices can be used as mosquito repellents. The essential oil of basil and piperidine alkaloid separated from long pepper repels mosquitoes. Medicinal properties. Herbs and spices are known for their medicinal properties and have been used in traditional medicines from the time immemorial. Powdered spices are either externally applied or taken internally for various ailments. The essential oils of many herbs and spices are used in pharmaceutical preparations. The essential oil of coriander is reported to be analgesic, dill and anise oils as antipyretic, coriander, celery, parsley and cumin oils as anti-inflammatory. Recently, anti-carcinogenic property has been reported for essential oils of cumin and basil, and this can be used as a protective agents against carcinogenesis. Also, methanol extracts of allspice, marjoram, tarragon and thyme strongly inhibited platelet aggregation induced by collagen in humans. India is known throughout the world as land of spices. Spice crops form an integral part of the agricultural economy in South Asian countries, especially in case of India, the largest producer, consumer and exporter of spices in the world. Spices are important additives that are essential to enhance or vary the flavor, aroma and color of foods. They are low volume, high value commodities and generally grown as cash crop by the farmers, which are a great source of essential oils and aromatic constituents and has a high demand in pharmaceutical as well as cosmetic industry. Standard ISO 676 in 1995 of the International Organization of Standardization defines spice and condiments as vegetable product or mixture that are free from extraneous matters used for flavoring, seasoning and imparting aroma in foods. The term applies equally to the product in the whole form or in the ground form. Spice may be derived from various parts of the plants like bark, buds, flowers, fruits, leaves, rhizomes, roots, seeds, stigmas and stylus or the entire plant tops. The term herb is used as a subset of spice and refers to plants which have aromatic leaves. Spices are often dried and used in a processed but complete state. Another way is to prepare extracts such as essential oils by distillation of wet or dry raw materials or by using solvents for extracting oleoresin and other standardized products. The most important spices traditionally traded throughout the world are the spice crops grown in tropical environment. The major exception to this group are the capsicum, that's chili peppers, paprika, and coriander, which are grown over a wide range of tropical and temperature weather conditions. Crop management and production of spices and essential oil is difficult in these wet and humid environments. Drying the crop to ensure good storage of products is particularly important, and in the wet humid environments, this creates the need for efficient and effective drying systems. In terms of quality, the major spice consuming countries like Europe and USA are demanding more and more quality compliance by the producing countries. To face this challenge, they have to prepare to produce, process and market high quality spices with internationally accepted food safety standards. Hence, the precautions have to be taken from the harvesting as well as primary processing, which includes washing, crushing, blanching, drying, cleaning, grading and packing in order to meet the standards. In the year 2018, India's spice production was estimated to 8.1 million metric tons. These spices include garlic, turmeric, coriander, cumin and cinnamon among variety of others. The Indian spice market is estimated to reach a value of about 18 billion US dollars by 2020. According to National Spice Board, India have exported a total quantity of 1,100,250 tons of spice valued 2,805.50 million US dollar in 2018-19. The estimated growth rate of spices demand in the world is slightly above the population growth rate. Across South Asia, smallholder production system dominate the spice farming economy. The fortunes of spice farming sector thus has a critical role to play in ensuring equitable development through enhanced livelihoods, security in small holdings in India as well as other South Asian countries. The trade distribution structure in the spice and herb trade can be divided into lines of supply to the three broad market sectors: industrial, catering and retail. The structure of the supply tree shows there are a number of different routes to market, and the most direct is the producer supplying directly to the industrial sector. It is estimated that about 85% of the international trade of herbs and spices is dried and cleaned for use in a crude form without further processing. Spices can be heavily contaminated with microorganisms because of the environmental and processing conditions under which they are produced. Before the spices can be safely incorporated into food products, the microbial load has to be greatly reduced. Flavor and aroma from a spice can be reduced with high temperature treatment because of the loss of volatile oils. Steam can also result in a loss of aroma and flavor components as well as color changes. It also results in an increase in moisture level. Until recently, most spices and herbs were fumigated with sterilizing gases such as ethylene oxide to control or destroy contaminating microorganisms. However, the use of ethylene oxide was strictly prohibited by European Union directive in 1991 and has been banned in more number of other countries because of its carcinogenic properties. Since then, irradiation have emerged as a viable alternative, and its usage and end results guaranteed cleaner, better quality herbs and spices in comparison to those fumigated with ethylene oxide. Irradiation is a cold sterilization process and is ideal to kill the microorganisms. This procedure is now widely practiced on a commercial scale. International Consultative Group on Food Irradiation (ICGFI) developed a code of good irradiation practice for the control of pathogens and other microflora in spices, herbs and other vegetable seasoning under the aegis of FAO, IAEA and WHO. The main purpose of irradiation is to decontaminate and sterilize the spices of microorganisms or insects and pests. It is important to note that irradiation is not used for the preservation of these ingredients, and proper preservation is obtained through proper drying, packaging and storage. Quality deficiencies cannot be corrected solely by irradiation. Some countries and market segments are reluctant to adopt irradiation, and there have been recent developments to sterilize botanical powders such as spice by contact with an oxygen such as nascent atomic oxygen. The Codex Alimentarius Commission adopted a code of hygienic practice for spice and dried aromatic plants in 1995. This code details hygienic requirements in the production harvesting area, in the establishment, design and facilities, for personal hygiene, for hygienic processing requirements, and the end product specifications. Harvesting is a major field process of collecting the cultivated crop product from the field when the crop attains physiological maturity and subjecting that product in controlled processing and stable storage conditions. The harvesting requirements will differ for the final product sort, and there are specific needs such as maturity and evenness that will dictate the harvesting management and timing. To draw maximum benefit from the crop, harvesting must be done at the right time and appropriate stage such as a maximum recovery of quality product is obtained and minimizes the field losses, thereby increasing the total yield. Care should be taken during harvest that no foreign matter is mixed with the harvested plant materials. Harvesting of plant parts should be done under the best conditions, avoiding dew, high humidity and rain. If the harvesting occurs in wet conditions, the harvested material should be dried immediately in order to prevent microbial fermentation and mold growth. Underground parts such as rhizomes should be cleaned from adhering soil as soon as possible after harvest. Cutting equipments, harvesters and other machines should be kept clean to reduce contamination from soil and other materials. Produce should be stored in a clean, dry place free from insects, rodents, birds and other pests and inaccessible by livestock and domestic animals. Rotting or contaminated plant material should be discarded during harvest, post-harvest inspections and processing in order to avoid loss of product quality. Black pepper vines flower during May to June. Pepper fruits take about 7 to 8 months after flowering to reach full maturity. Normally, a single harvest is done in India. The spikes are nipped off by hand and collected in bags. The stage of harvest depends on usage of the crop, black, white, oleoresin, etc. For black pepper preparation, harvesting of the berries are done when one or more berries on the spike turn red, or when the berries can be easily separated from the spikes upon rubbing between the hands. For white pepper preparation, the berries are harvested when ripe. Small cardamom plant starts bearing 2 to 3 years after planting. The capsules ripen within a period of 120 to 135 days after its formation. The harvesting generally commences from June to July and continues up to February depending on the varieties cultivated and climatic conditions. The peak period of harvest is during October to November. The capsules are harvested 6 to 7 times at an interval of 15 to 30 days. Just ripened capsules are harvested, which is indicated by dark green color of fruit and black colored seeds. Large cardamom starts flowering during May and continues up to August. It takes about 4 months for the fruits to mature after flowering. Harvesting is done by collecting panicles containing ripe fruits with the help of special chisel-shaped narrow knife. Harvesting is done only once in a year when all the fruits are uniformly ripe in panicle. After harvesting, the individual capsules are separated from the spikes by hand. An operation locally known as light cherry is also carried out during harvest, where old sterile dried shoots which do not bear fruits are removed. Ginger rhizomes are harvested from 6 months onwards for marketing the produce as green ginger. Normally, it takes 7 to 8 months for maturity depending on the time of planting, climatic conditions and management practices. The stage of rhizome harvest or maturity has greater influence on quality characteristics and suitability for consumption and processing for various end use of or products. Fiber, volatile oil content, and pungency levels are the most important criteria in assessing the suitability of ginger rhizomes for processing. Rhizomes are harvested when the leaves turn yellow and start drying up gradually. The clumps are lifted carefully with a spade or digging fork, and the rhizomes are separated from the dried up leaves, roots, and othering soil. A prototype tractor drawn ginger harvester cum elevator was found suitable for harvesting the ginger crop. Turmeric crop is ready for the harvest after about 7 to 9 months after planting, depending upon the variety grown. Usually the harvesting period extends from January to March. The rhizomes are dug by manual labor when the leaves turn yellow, fade and dry up. A light irrigation is provided prior to digging to ease and speed up the harvesting process. Rhizomes are subsequently cleaned and fingers are separated from mother rhizomes. Chili harvesting is done according to the purpose of end use. Crop starts yielding green chilies in 40 to 50 days after transplanting. Dry chilies can be harvested in 70 to 80 days after transplanting. Fruits are hand-picked. Normally, first 2 pickings are taken for green chilies and subsequent harvesting is for red dry fruits. For dry chilies, care should be taken that the fruit should not be ripened or over-ripened. Vanilla beans develop quickly and obtain a full size in 6 weeks after pollination. However, it takes 8 to 11 months for maturity. Beans are dark green in color when immature. Vanilla is ready for harvest between 6 to 9 months after flowering. The optimum time for harvesting of bean is when mild yellowing commences from its distal end. If left on the vine, the bean turns yellow and starts splitting. The well-ripened ready beans detach easily from the bunch just by lifting them in reverse direction. Immature beans do not detach easily from the stalk. Hence, to pick the beans at dry stage, the plantation should be visited frequently. The green beans do not possess any aroma. Processing and curing should commence within a week of harvest. Saffron plant flowers during mid-October and last only for 15 to 20 days. Harvesting of saffron is a very difficult job and labor intensive. Saffron flowers are hand harvested in the morning hours by picking with fingernails at the pedicle. The flower wilt within a few hours of harvest. The separation of stigma from the flower is tedious operation and is done immediately after the harvesting. Tree spices. Clove tree starts flowering during September to October in plains and December-January at higher altitudes. Trees begin to yield from 7 to 8 years after planting and full bearing stage is attained after about 15 years. Flower buds are produced on young flushes and it takes about 4 to 6 months for the buds to harvest. Flower buds are harvested carefully in clusters when they turn from green to slightly pinkish tinge and attain 2 cm long. The crop is ready for harvest from February to May in Indian condition. For tall trees, platform ladders are used. Timing of bud harvesting is very important as the value of clove goes down significantly when the bud is allowed to open. Nutmeg trees raised from seedlings begin to bear at 5 to 8 years after planting, whereas vegetatively propagated trees start bearing in 4 to 5 years. Fruits are reported to ripen 6 to 9 months after flowering. In India, fruits that split on the tree exposing crimson colored aril are harvested. Peak season of harvest is from June to October in Konkan region and June to July in Kerala. The split fruits are collected from the tree by hand or with the help of long pole or allowed to fall naturally on the ground and are collected every day. After harvesting, the outer fleshy rind is removed and the maize is detached from the seed shell by hand and flattened out. Allspice trees usually flower during March to June in India. Male trees flower early as compared to females. Under well-managed gardens, clonally propagated plants start flowering in 3 years and seedling plants in 5 to 6 years. The berries are ready to harvest in 3 to 4 months after flowering when fully grown greenish in color. Allspice does not set fruits in the plains. Spraying paclobutrazole induced flowering increased number of panicles, flowers and settings of berries which resulted in higher yield. Cinnamon trees attain a height of 10 to 15 meter, but in cultivation, coppicing is practiced from 2 to 3 years onwards. Plants are copied during June to July to a height of 12 cm from the ground level. The subsequent harvest is made between 12 to 18 months. The stumps are earthened up, which encourages the development of side shoots so that the plant will assume the shape of a low bush of about 2 meter height. Stems are cut during rains to facilitate peeling. A test cut can be made on the stem with a sharp knife to judge the suitability of the time of peeling. Best time for peeling is when the new fleshes and leaves are hardened after a rainy season. Regular peeling operation are commenced from 4 to 5 years. The best quality is obtained from the thin bark of shoots in the center from the middle portion of shoots. Fully developed shoots of 1.5 to 3 cm diameter and 1.0 to 1.25 meter length are harvested. Such shoots are carried to the peeling shed after removing the leaves and terminal shoots. Tamarind plants starts flowering in 8 to 10 years after planting when raised by seedlings, and vegetatively propagated plants in 4 to 5 years, and economic return starts from 7 to 10 years. Fruits mature and ripen in 10 to 11 months during February to April after flowering in India. Fruits are harvested both immature and mature from December to April depending upon the demand in market and their uses. At maturity, the pulp color changes from green to brown and dark brown or black or red depending on the types. The shell, exocarp, gets hardened and separated from the pulp, mesocarp. Fruits are harvested by shaking the branches and collecting the fallen fruits. In subsequent harvest, the leftover fruits are picked using fruit picker. The fruits do not usually get spoiled due to high acidity. Seed spices. Seed spices are annual herbs whose dried fruits or seeds are mostly used as spices. There are about 20 seed spices grown in India, and out of them coriander, cumin, fenugreek and fennel are considered as the major seed spices, whereas celery, dill, ajwain and seed nigella constitute minor group of seed spices. India is the world's largest producer, consumer and exporter of seed spices. Coriander crop matures in about 90 to 110 days after sowing depending upon the varieties and growing season. In certain varieties, leaves are harvested up to 50% at 60 days and 75 days after sowing to obtain extra income without affecting the seed yield. The coriander crop grown exclusively for green leaves is harvested after 35 to 40 days after sowing. Harvesting should be done when the fruits are fully ripe and 50% seeds turn brown. Delay in harvest should be avoided as it causes shattering and splitting of seeds during harvest and subsequent processing operations. Cumin crop is generally harvested in about 100 to 110 days after sowing when the plants turn yellow but not completely dry to get high oil content in seed with good color and higher yield. Harvesting is usually done in the morning hours by cutting or uprooting the whole plants to avoid shattering losses. Fenugreek comes to harvest in about 90 to 120 days after sowing. Harvesting should be done by cutting the plants with sickles when the lower leaves started shedding and color of pods turned yellow. Delay in harvest leads to shattering of seeds. Harvesting in the morning hours is preferable. The effect of nitrogen rate and the cuttings on green and seed yield of fenugreek. The study conducted on that, and it is reported that there is additional benefit of leaf yield with increased seed yield when cutting is done at 60 days after sowing. Fennel crop matures in 210 to 240 days after sowing. In fennel, all the umbels do not mature at the same time. Hence, picking is done when seeds are fully developed but still green. Harvesting is completed in 3 to 4 pickings at an interval of 10 to 12 days. Good quality chewing type Lucknow Samph is produced by harvesting the umbels at 30 to 40 days after pollination. At this stage, the size of the seeds is half of the mature fruit. Celery is a biennial plant and produces seeds in the second year in hills, whereas in plains, crop mature in about 150 days after transplanting. Harvesting should be done when the umbels dry up and the individual seeds darkens and falls at the slightest touch. There is a problem of seed shattering in celery. Spraying of polyvinyl acetate glue on umbel prevented shattering and increased seed yield by 33% over control. Dill crop takes 130 to 150 days after sowing to attain seed maturity and is ready to harvest by end of March. The terminal umbels are hand-picked when the seeds begin to pale yellow or light to dark brown in color. The rest of the crop is cut at the base or pulled out when the tertiary umbels begin to turn brownish and threshed by gentle beating the umbels. The crop is prone to shattering, so harvesting should be done at the right stage and in the morning hours to avoid losses. A Nigella crop ready to harvest in 140 to 160 days after sowing, when the seeds have attained full maturity in capsules and have turned to full black in color. The crop is harvested by cutting at the base or pulling out the whole plant. Delay in harvesting may cause shattering of seeds. Post-harvesting operations. Like all other agricultural commodities, spices invariably contain high moisture, 55 to 85% at the time of harvest, which must be brought down to 8 to 12%. Furthermore, spices also vary in shape, texture, size, color, etc., as they may be fruits, berries, barks, seeds, leaves, rhizomes, roots, flower parts, etc. Therefore, their pre-treatment such as curing, cleaning and methods of processing also vary considerably. During their post-harvest processing, they are also subject to different types of unit operations such as washing, peeling, curing, drying, cleaning, grading and packaging until they are ready for the market. It is very important that all spices be harvested at the correct stage of maturity without much physical damage, after which they are processed properly for the market. In most cases, spices are sun-dried at the farm and further transported to different units for processing. Processing operations vary considerably with the individual spices concerned. Washing root and rhizome spices such as ginger, turmeric, angelica, onion, which are dug out of the soil, need washing to remove the othering mud and dirt. Pressure water washing can also be done where the facilities are available. Reduction in the microbial load will also be influenced by the efficacy of these operations. Peeling. Almost all spices are dried whole without peeling with the exception of ginger, onion and garlic. The skin of ginger rhizomes constitute a barrier to evaporation or transpiration of moisture from within. Hence, a prerequisite for efficient drying of ginger is peeling. Cassia and cinnamon barks are peeled off the tree branches 2 to 3.5 cm thickness with the help of special curved knives, cut into convenient size before they are cured and dried as quills, featherings and chips. In nutmeg, the outer rind is removed, exposing scarlet mace, which is gently detached and dried in partial shade. Seeds are also sun-dried. Pricking is done mostly in chili to help reduce the time of drying and for better retention of color and overall quality. The same applies to capsicums and red paprika. Blanching is universally practiced in vegetable drying and rehydration, chiefly for the inactivation of enzymes, but exception of celery, garlic, onion and parsley, which are valued primarily for their specific flavors, since blanching involves the very enzyme involved in the generation of their respective flavors. Blanching is not desirable in chili and ginger. However, blanching or simmering is a commercial practice in the case of turmeric, particularly in the presence of an alkali, that is dilute lime water or sodium bicarbonate. Advantages of blanching of black pepper is that blanched berries require only 2 days for drying in the sun. The dry pepper has an attractive uniform black color. Blanching minimizes microbial contamination and thus gives a more hygienic product. Likewise, for the preparation of dried dehydrated green pepper as well as white pepper, hot water treatment is given in several countries. Different spices such as cinnamon, cassia, garlic, saffron, turmeric and vanilla beans are cured by different techniques in order to generate the characteristic flavor or aroma for which they are valued. Cinnamon and cassia peeling and curing. The peeled bark of cinnamon and cassia branches are gathered and packed one above the other with their concave and convex surfaces in juxtaposition until the packing measures up to 20 to 30 cm wide and 30 to 40 cm long. These leaves are then piled up within enclosures of stick and wrapped up in mats. The packs are kept overnight in the condition for curing or for allowing fermentation. Actually, no real fermentation occurs, but bark soften, rendering it easily pliable for subsequent piping operation or the removal of the epidermis and green cortex. Smoke curing of garlic. The better quality of smoked foods is due to the partial dehydration, incorporation of natural antioxidants, impregnation of antiseptic constituents, effect of heat on microorganisms, and improvement of organoleptic quality. Curing of saffron. The value of saffron primarily depends on the method by which stigmas are processed. Great care must be taken so as to protect the stigma against dampness as well as light, because light bleaches saffron to a dull yellow color. Drying in the sun or over smoking also bleaches the saffron and changes its color. Curing of turmeric. Curing of raw turmeric rhizomes and fingers freshly dug out of the earth is essential for the development of attractive yellow color, mostly due to curcumin and aroma. Without curing, it's black. Curing, it lacks both. Curing begins 3 or 4 days after harvesting. The mother rhizomes and the finger are separated by hand if necessary. The former are kept for seed purposes. The latter is cured for marketing by the following techniques, such as conventional techniques and improved scientific method. Conventional technique, the fingers and the bulbs are boiled in water until froth comes out and a white fumes start to appear, giving the typical turmeric aroma. The fingers and bulbs become softer and yield when pressed between fingers. At this stage, they are removed from boiling water, drained properly, colored artificially if necessary, and dried in the sun for 10 to 15 days. After which, they are polished to remove any othering, rootlets and scales. Improved scientific method. A new scientific method of curing turmeric has been developed by Central Food Technological Research Institute, Mysore, according to which the washed raw tubers are boiled in dilute lime water, sodium carbonate or sodium bicarbonate instead of water, with diluted lime water instead of sodium carbonate or sodium bicarbonate. For imparting a characteristic yellow color to tubers, a solution containing 20 g of sodium bisulfite and 20 g of concentrated hydrochloric acid per 150 pounds or about 70 kg of boiled tubers has been recommended. Curing of vanilla beans or pods. Normally at the time of harvest, the aromatic components forming the characteristic vanilla flavor do not exist in vanilla beans or pods, but appears only after curing, involving enzymatic actions on glucosides, the most important of which is glucovanillin, which produces vanillin, the main aromatic component of vanilla, and sugar as a result of the action of beta-glucosidase. Similarly, aldehydes, catecholic acid, benzoic and vanillic acid, anisec alcohol, etc. are formed. This different compound impart subtlety to the fragrance of natural vanillin, enabling it to be distinguished from synthetic vanillin. Fermentation of vanilla is characterized by the following different stages. Cessation of the vegetative life of the bean to allow the onset of enzymatic reactions. Rising the temperature to promote this action and to stimulate rapid drying, thereby preventing the appearance of harmful fermentation. Slower drying followed by the production of different fragrance components. Components of the product during which the conditioning of the product during which the operations geared to commercial presentation and to obtain good preservations are carried out. Threshing is the process of removal and separation of fruits or seeds from unwanted flower stems or plant stalks, as well as removing damaged or immature material. This process can be done manually by hand with the help of sieves and screens, by use of winnowing or by mechanical shakers and sorters. Pepper spikes need to be washed prior to threshing or threshings to remove dust and dirt. Harvested spikes are spread on a clean floor and threshold, manually by trampling or by using a mechanical thresher. The berries are also graded at this stage by removing undersized berries, which are then put into different sized categories. Seed spices are threshed by beating with wooden or bamboo sticks. The threshold stalks are then cleaned by winnowing in natural air steam or in artificial air stream using electric fans. Center for Research on Seed Spices, CRSS, Jagudan tested modified threshers in villages for cumin and fennel crop, and it was found that the net return of 3.25 and 3 per kg for cumin and fennel respectively was obtained as compared to traditional method. Next step is drying. Drying is the most important process in the production of dried herbs and spices. The main purpose of drying is to reduce the moisture content of the product from actively growing in the field to a level that prevents deterioration of the product and allows storage in a stable condition. Drying consists of two-stage process. First one is the heat is transferred from the moist product to vaporize the water in the product. Next step, mass transfer of moisture from the inside of the product to the surface where it evaporates. The most important and immediate management concern is to ensure that the harvested crops will not rot or become grossly invaded with yeast, bacteria and mold, producing aflatoxins or becoming contaminated by pests. This is the start of the preservation process, which for most spice crops require drying that will enable the long-term crop storage and the opportunity for further processing. The drying phase of post-harvest management can include 4 preliminary stages. The selection of high quality produce from the field, cleaning the crop by washing and disinfection, preparing the crop for drying by peeling or slicing, pre-treating with antioxidants, blanching or sulfuring. Sometimes field contaminants, that is dust or soil, can be removed by washing prior to processing using antimicrobial solutions to reduce the microbial population to a low level prior to the drying process. Drying of seeds and fruits. The immediate drying in pepper after threshing and blanching. The fruits are dried in the sun for 7 to 10 days until the moisture content is about 10% and the seeds have the characteristic wrinkled appearance of black pepper. Pepper drying in the sun has to be turned over periodically to aid uniform drying and discourage mold infestation. The main disadvantage of sun drying is the lack of uniformity and the potential contamination by microorganisms. Different types of dryers such as solar and mechanical dryers have been developed which are highly efficient for drying pepper. Nutmeg and maize fruits are dried in their shells under the sun and turned each day to prevent fermentation. The nuts are considered sufficiently dry when they rattle. Once dried, the nuts can be stored for a considerable period of time. Nutmeg, when dried in solar tunnel dryer, showed a high reduction in drying time. Dryers took about 8 hours for drying from an initial moisture content of 42.6% to 7.2%, while the conventional drying practice took about 13 days. The maize is separated and flattened by hand and dried on mats under the sun. This takes between 2 to 4 hours. Programmed drying or enzymatic developments of flavor compounds. Vanilla. During the curing process, vanilla pods develop flavor as a result of naturally induced enzymatic action. The final quality of vanilla depends mostly on the glucovanillin content in the green bean. This means that the quality of cured beans improves where the temperature is maintained to encourage the slight fermentation, and flavor will be higher if the curing starts with the mature beans that have the highest glucovanillin concentration. A number of procedures have been developed for curing vanilla and they can be characterized into 4 stages. The first operation is to halt the plant's physiological functions by stopping vegetative development so that the various enzymes can come into contact with the cell substrates. Sun or oven welting or hot water scalding is the most practical method. The second operation, that is the most crucial step, is sweating. Bean moisture is initially allowed to escape rapidly to get to a level that will reduce the risk of microbial spoilage during the subsequent processing. The curing enzymes are most active during this stage and vanillin and related compounds are released during this step that takes 7 to 10 days. The cured beans are with 60 to 70% moisture at the end of the sweating process, which is too high for safe storage. The third operation is drying in order to protect the beans from microbial spoilage and also to inhibit further enzyme activities and biochemical changes. The bean should contain 25 to 30% moisture at the end of drying. The fourth operation is to store the beans in a closed boxes for several months while chemical reactions take place. The Mexican process, sun method, and the Madagascar process, Bourbon method, are the 2 main methods for curing vanilla beans. The Mexican method begins with the shed storage for some days until the beans start to shrink. The beans are then placed in sweating boxes for developing enzymatic reactions. This process of wilting and sweating may be repeated a number of times during the early part of curing and extend over 2 to 3 week period. The moisture is reduced to the desired level of 25% by frequent exposure to sunlight and sweating. The final curing occurs when the beans are matured in boxes for 2 to 3 months. The Mexican process of curing takes 5 to 6 months. The Madagascar process is faster and begins when the pods are dipped in hot water at 80 degrees Celsius for 7 to 15 minutes. The beans are then spread out on blankets in the sun and when well heated and rolled in blankets to start and ferment overnight. This procedure is repeated over 10 days. At the end of this period, the beans are placed on trays and allowed to further cure and dehydrate. The Madagascar process takes 35 to 40 days. Drying to retain colors. Cardamom capsule color and retention of greenness are important for the highest quality. Capsules cured immediately after picking and retained greener color, and the loss of greenness was more significant if the capsules were stored for more than 12 hours. Bagging of the capsules in jute bags and cool storage aids the retention of greenness. Cardamom capsules contain 70 to 80% moisture during picking. Due to bleaching and capsule splitting, sun drying is not suitable for cardamom. Full pipe curing drying is the most convenient method from which high quality green capsules can be obtained. The structure consists of walls made of bricks or stones, tilted roof with ceiling. A furnace is situated on one side of the chamber. Heat is generated by burning firewood or farm waste. A pipe made of iron or zinc sheets starting from the furnace passes through the chamber and opens outside the roof. The heated air current generated in the furnace passes through the pipe and increases the temperature of the room. The fans located on either side of the wall uniformly spread the temperature. Inside the room, fresh capsules are kept in the wood and aluminium trays with spacing of 20 to 22 cm between the trays. The fire in the furnace is regulated to maintain a temperature of 40 to 50 degrees Celsius. High quality green cardamom can be prepared in 18 to 22 hours. Drying leaves and stems. During drying, the harvested leaf and stems contain 80 to 90% water. It transforms to a stable state containing 5 to 10% water. The temperature during drying is critical, and if the drying temperatures are too hot, the volatile compounds are lost. In general, drying temperatures should be below 40 degrees Celsius with forced air movement. Drying flowers and buds. Clove buds are spread over a clean concrete floor and dried in the sun. Gentle raking occasionally will aid in even drying, and it is important to overcome heating and mold formation. Damaged and spoiled buds are removed during this phase. Drying is completed in 4 to 6 days with buds losing about 2/3 of their weight with moisture content or not more than 12%. Saffron flowers should be picked and dried on the same day, followed by separation of stigma from the floral parts. The stigma contains about 85% moisture at field picking and should be reduced to the moisture level close to 10% by drying, which will prolong the storage of filaments. To obtain high quality saffron, drying temperature should initially be high 90 degrees Celsius for a brief period less than 20 minutes and then continue drying at lower temperature. Irrespective of drying method, it is important not to over dry to a brittle stigma. The duration of drying is dependent on the drying temperatures used, and the higher the temperature used, the shorter is the drying time. Drying of roots and rhizomes. Turmeric rhizomes has to be cured after harvest to enhance both color and aroma. Steaming or boiling the fresh rhizomes in a lime or a 0.1% sodium bicarbonate solution is a traditional method of curing rhizomes. The curing is to remove the raw odor, reduce the drying time, gelatinize the starch, and produce a more uniformly colored final product. Traditionally, the cooked rhizomes were spread in the sun, and this process takes 10 to 15 days. The final moisture content should be close to 6% moisture content. Drying seed spices. Generally, seed spices are dried in sun and are usually adequate to dry the product, but there is a chance of contamination of the materials by dust and the dirt and reduction in volatile components. Mechanical dryers could enhance the quality and post-harvest losses. CRSS Jagudan developed different dryers and found that the low-cost poly-solar drying was the best for the fast drying at 32 hours as compared to other drying methods. Shade drying is the best to maintain green color of fennel and to avoid loss of oil in dill. Grinding and separation. Grinding the herbs or spices to a specified particle size using a standardized sieve aperture is a normal processing activity. Grinding gives easier mixing in the final food product and aids the dispersion of flavor throughout the food. A food manufacturer will have specific particle size requirements and will have to mill the herb or spice to sieves that will obtain the fitness required. There are certain examples such as white pepper, cardamom. White pepper is produced by removing the pericarp fruit wall from the mature or semi-ripe pepper fruits and then grinding. Traditionally, white pepper is prepared by steeping ripe fruits in water for a few days, rubbing or remove the pericarp and later washing and drying. The berries that begin to ripen are put into bags and soaked in water to soften the pericarp, which is then washed off and the seeds are dried in the sun. The quality of the water used for soaking the berries is important as pepper soaked in muddy or dirty water may be discolored or have foreign odors. Soaking tanks and clean waters produce pepper of higher quality. For black pepper, berries are harvested and when mature green, de-spiked and dried in the sun. For both black and white pepper, the quality of the product is dependent on the weather as almost the pepper is commercially sun-dried. Cardamom capsules should be sorted into size classes and different size sieves will allow different grade to be separated as well as the separation of split and insect infested capsules. In addition to green capsules, there is a bleached cardamom product that is creamy white or golden yellow in color. Dried capsules or freshly harvested capsules can be bleached. Nutmegs are grouped under the three broad quality classes: sound, nutmegs that are mainly used for grinding and for oleoresin extractions; substandard, nutmegs that are used for making powder, oleoresin extraction and essential oil distillation; and poor quality nutmegs for essential oil distillation. The shelling of nutmegs can be undertaken by hand or machine and care is necessary to prevent the bruising of the kernels. Flotation in water is used to remove unsound kernels as these kernels are lighter than water and float. Capsicum, chili peppers and paprika. Color retention is improved by the application of fat-soluble antioxidants and the addition of these antioxidants is more effective after curing than before and in the ground of spices rather than whole pods. The spice should be uniform fine powder, orange to dark red with hot biting taste. Paprika pepper is relatively coarse, bright to brilliant red powder, spicy and only mildly pungent flavor. Turmeric is a dried rhizome, has a dull and rough outer surface with scales and root beds. Smoothing and polishing the outer surface by manual or mechanical rubbing improves the appearance. Manual polishing consists of rubbing the dried turmeric on a dried surface. The mechanical methods can be hand-operated barrel drum or power-operated drums. The turmeric rhizomes are rotated and the polishing occurs with the abrasion against the metal mesh of the drum and mutual rubbing of the rolling rhizomes. In India, the yield of polished turmeric from the untreated rhizomes varies from 15 to 25%. Cryogrinding. The main aim of the grinding spices is to obtain smaller particle size with good quality product in terms of size, color and flavor. In normal grinding, the temperature of the product may rise to an extent of 42 to 93 degrees Celsius, depending upon the oil and moisture content of the spices, which is responsible for loss of volatile oil and flavoring constituents. The losses of volatile oil for different spices have been reported to be in the order of 40% in coriander, 37% for nutmeg, 14% for mace, 17% for cinnamon, 17% for oregano. This loss of volatile oil can be significantly reduced by adopting cryogenic grinding technique using liquid nitrogen or liquid carbon dioxide. The extremely low temperature solidifies oil so that the spices become brittle, hence crumble easily, permitting grinding to a finer and more consistent size. Finely ground spices spread their flavor uniformly throughout the food product in which these are being used. Volatile oil content for cumin seeds is increased by 43.3% and coriander seed is increased by 172.7% compared to conventional grinding. Goodbye for today. Continue your studies with IIOCS.com Food Tech Club. For any queries, contact the number on the screen.